This workshop continues looking at the ideal gas law. The animated GIF you can see is showing a closed system at constant temperature. So if V goes up, P goes down, and vice versa. The line the dot moves along is called an isotherm, and it's always that shape, even if the axes here are the opposite way to the way we usually show them. There are terms that we use that you'll need to remember, so I'll go through these next. The equations used in this workshop are also shown. Firstly, an adiabatic process. That means no heat transfer in or out. The clue that a process is adiabatic is if it happens really fast, so there's no time for heat transfer, or if the container is well insulated. Isovolumetric means volume doesn't change. You'll know this is the case if you're told that it's a fixed size container that can't expand. Isobaric means pressure doesn't change. This requires a container like the one you analysed in last week's workshop, where atmospheric pressure and the weight on the piston keep a constant pressure inside. Isothermal means temperature doesn't change. This kind of process has to happen slowly in a thermal reservoir to allow the temperature to equalize. The internal energy of a system is a measure of the energies of the gas particles inside. You can increase the energies of the particles by heating it or by compressing the system, that is, doing work on it. The effect on the particles of doing either of these things is the same. They move faster, so they have more kinetic energy. So we sum this up in the equation that says the change in internal energy is the heat added plus the work done. So work done means a change in volume. Our convention is that it's work done on a gas, and it's given by the integral shown. It has a negative sign because positive work means the volume decreases, and the integral limits are always with V final at the top, as shown. Finally, where does work fit into the PV graph we've been seeing? The work, which is the integral of P dV, is the area under the PV curve. In the process shown here, the pressure increases as the volume decreases, and a decrease in volume means positive work. So if the arrow goes to the left in a process, then positive work is being done. This should be all you need to be able to do the workshop problems.